Okay, so before I really dive in here, I just want to let you know, and for some of you for whom this sort of thing helps, you may want to take a minute and actually go find it right now. But there's a document in our Canvas page. If you look at week 5, there's this document that says Lesson 12 handout, and if I click on that, it's basically an outline of what we're going to be doing in this lecture, so you can sort of follow along with where we are. And as we're talking, I'll for many of these sections, I'll be saying, okay, we're on 2.1 now, we're on 2.2 now, whatever. If that doesn't seem like a big help to you, then you can just ignore it. But if that looks cool to you, then it's there. You can access it from the Canvas page. Okay, so a pointer is a variable that, instead of storing data, stores the memory address of some other variable. It's called a pointer because we think of this memory address as a way for the pointer variable to point to the other variable. You've actually seen situations similar to this already, right? You haven't actually seen technically a pointer, but you have seen variables that store the memory address of another variable. That would be a pass by reference parameter, right? So in C++, there are 2 different types of variables that store memory addresses. One is called a reference variable. That's what we studied when we were doing pass by reference parameters. Hopefully you're all pretty comfortable with that by now. Pointers are a second C++ construct for a variable that stores a memory address. The rules are a little different, but I just wanted to put that out there so that you don't feel like this is a completely new idea. We have talked about the idea before. Let me talk about a few ways that we use pointers in programming. Probably the most important use of pointers in programming is when we get to talking about linked data structures. Okay, so just to give you the 25 words or less definition of what that is. We've seen that arrays are pretty inflexible, right? We're going to see how we can make arrays a little more flexible, but in any case, anytime you're using an array, it's going to be a challenge if, for example, the array is full and you want to add one item, or you want to delete one item from the middle of an array. A linked data structure is a data structure where each element of the container, each element of the data structure has the piece of data, but then it also has a pointer to the next element in the data structure. Sounds complicated, but the advantage is if I need to delete something in the middle of that data structure, it's very efficient and easy to do. If I want to add something to that data structure, if I want to add one item to that data structure, it's very simple and easy to do. So anyway, we'll be talking more about that at the very last topic in our course. Second use that we'll be seeing much sooner than that is dynamic arrays. And those are just arrays that are a little more flexible than the non-dynamic arrays that we studied last week. So we'll be talking more about that on Wednesday, probably. And then a third application, which is actually kind of the same thing as dynamic arrays, but it's such a big deal that I'm breaking it out and making it a separate use is when we talk about C strings. So we have talked a little bit in this class about the string type. I don't think you've had to use it in any programs, but we did study it. And actually, we're gonna be looking at it a little bit more later in this lecture. So I'm not going to go into too much of a review right now. But there are two different ways to handle strings in C++. You can use the string type, otherwise known as the string class, otherwise known as string objects, which is what we covered in lesson 2 already this semester. Those are very nice. They're easy to use. They're full featured, safe. Then you have C strings, which is what C++ inherited from the C programming language. Much more of a raw, primitive data type. But we will be studying C strings in some detail this semester. And when you use C strings, typically you're going to be using pointers to use them. Okay, so all of that just to say, there are some very powerful uses of pointers. On the other hand, I'm going to say that probably more than any other topic in this course, you sort of have to trust me on that. When we first start studying pointers, it's going to feel a little bit like, okay, this is fine, but why would we ever want to do this? So you sort of have to suspend disbelief just for a little bit, take my word for it that this really is going to have some use, and do your best to just learn the sort of more, learn the details of how to use pointers without really understanding how it may actually be helpful at first. Okay, any questions about any of that before I dive in and show you some code?
So a pointer is a variable that holds the location of another variable, right?
Correct.
What about a pointer that holds the location of another pointer?
Well, it would still be a pointer.
Is that a thing?
It would just be, but that's possible. It's I wouldn't say it's common, although you do see it sometimes. Sounds kind of complicated, right? Probably something you want to avoid if you can, but there's nothing new about that, right? You would declare it the same way you would declare a pointer to an int. It would just be a pointer to an int.
Okay.
Yeah. Okay. All right, let me turn this into a comment so that it doesn't get in the way when it comes time to run some code. I was going to say just one more thing about pointers by way of introduction, and that is, and tell me if you find this to be not true, but in general, I think there are a lot of topics we're going to study that are, I guess I would say, conceptually more difficult than pointers, maybe more abstract than pointers. Pointers are very concrete, logical. The only hard part about pointers is just that there's a lot of details to keep track of, and it can be tedious, right? But there's nothing really conceptually difficult about it, I don't think. So that's just, I don't know, maybe to give you some more categories to put things in as we're talking here. All right. So this subject, so in my outline, topic 1 was, actually, let me just go ahead and do this. Why not? Topic 1 was basically like intro to pointers, including things like uses of pointers, right? So now we're on point number 2 in the lecture, and 2.1 is going to be how to declare a pointer. And here's that. Okay, so what this means is, right, if I just said int pointer, that would be declaring an int variable. If I want to store a variable that is of type pointer to int, I just put a star after the word int, and that makes it so that instead of int pointer being an int, it's a pointer to int. Okay. I have to talk a little bit about where the star goes and how it can be confusing. This is a little bit of a side point. So if you start to get lost, don't worry, we'll be back in a minute. But it turns out that the compiler doesn't care where you put the star. You can put it next to the word int, or you can put it next to the name of the variable. Either way is fine. However, two things. One is it's more common, and I think it makes more sense to put the star next to the type, because that's really what you're modifying, right? You're saying int pointer is not a variable of type int, it's a variable of type pointer to int. The problem with that is that the compiler sees it as being next to the variable. So if I say, if I say something like this, the compiler sees that as one variable of type pointer to int and one variable of type int, right? Because it's seeing, when the compiler looks at this, it's seeing that. Okay, so if that's confusing, I have good news for you. The best way to not have to deal with that at all is just every time you declare a variable, declare it on a separate line, and then you don't have to worry about that possible confusion. Okay? Any questions before I keep going here? All right, so as we go through this, I'm gonna, every step of the way, I'm gonna draw a picture of what's going on, okay, in the computer's memory. So here's what we have so far in the computer's memory. I have a variable named int pointer, which is of type pointer to int. And I have a variable named int pointer 1, which is also of type pointer to int. And neither of them have been initialized. So I'm just going to say that right now they are junk, just like any other variable would have junk in it when we first declare it and we don't initialize it. Okay. All right. What's next? Okay. Next thing I want to show you is we've got this thing called the address of operator. So I just realized that my chat. So here's an example of using the address of operator. I want to create an int variable, and then I want to make int pointer point to it. Okay, so let's say here I'm going to create a variable named I, and I want to make it so that int pointer, instead of having garbage in it, points to the variable I. Oops, that's not what I meant. Okay. I think this is going to be clearer if nope. Sorry, having a little difficulty with that. So let's try that. All right, good enough. Okay, so that's the goal. I want to make it so that int pointer is pointing to the variable I. The way we do that is First, I'm going to declare the variable I, and then I'm going to say int pointer gets, right? Because what I want to change what's being stored in that variable. So I'm going to say int pointer gets the address of I. Okay. That ampersand there means the address of. Let me just say ampersand has some other meanings in C++ too. So my advice is don't try to get them mixed up. Don't try to understand why you're using the same symbol here as you do in other places. Just think of this as a completely different use of the ampersand, and it means address of. So that means whatever the address of I is, store that here into this variable int pointer. And the way we draw a picture of that is we draw an arrow going from that variable to I. Any questions? Okay, moving right along.
So it's not the value of I, but the address of I, right?
Correct. What is being stored in the variable int pointer is not the value of I, which actually at this point we don't even know, right? It's just junk. It's the address of I. Yes, that's correct. We'll do a cout statement in a second so that you can see that. Let's see how that works. Okay. Up next, we have the dereference. Of course, as soon as I make my window smaller, I come to the first line that's longer. Or indirection operator. Okay. As it turns out, we rarely use the address of operator. It's pretty uncommon. You will see it. I can think of like one time this semester, after this week, I can think of one time where you'll actually have to use the address of operator. However, this next one, the dereference operator, you're going to be using constantly, like every line. If you have a program that has a lot of pointers, you know, like almost every line of code is going to have this in it. So what I want to do now is I want to put a 47 into I. Okay, that's my goal. I drew the picture first to show you what my goal is. And now I'm going to show you the code to make that happen. Well, one option would be I gets 47, right? However, that would not be learning anything new. We're trying to learn about pointers here. So I'm going to show you how to put a 47 into I without actually using the variable I. In other words, I'm going to show you how to put a value into I indirectly. So that's why we use the word indirection operator, right? We're using indirection here to put a 47 into the variable I without actually using the variable I. I'm going to digress just for a second here and say, you may be thinking, why would we ever want to do that? Why not just use I? The answer is almost all the time when we are using pointers, the variable being pointed at actually, it turns out, doesn't have a name. So we have to do it indirectly. So at least that's one reason why we do it this way. Okay, so now that I've explained why we do it that way, here's how we do it that way. Oops, typing someplace, no idea why. Okay, so as you can guess, the star here in front means don't put the 47 into the variable int pointer. Put the 47 into the variable that int pointer is pointing at. All right, so that's called dereferencing int pointer. Okay, any questions about what's going on there? That's how we get the 47 in here without using the variable I. Joseph, I'm going to ask you to hold on to that question. We are going to see that in a few minutes. Actually, we might not see it until Wednesday, but it's actually very common. And this is kind of going back to what I said about some of this is just going to be like, not going to make sense why we'd ever want to do this for now. For now, we're just going to learn how to do it, and I'll show you when it's applicable soon, okay? All right, I did want to just say quickly about that star. I remember being super confused about this when I was first learning it, which was a long time ago, because I was trying to figure out why the star here and the star here are the same thing. And I think the best way to think about it is just think of those as being two completely separate, unrelated uses of the star, okay? Up here, we are declaring a variable, and so we put the star next to the type, and it means pointer to int instead of just int. Down here, we're doing something completely different from that. We're using the star in a completely different way to mean dereference the variable. All right, let's go ahead and do a cout statement to see, so we can see for ourselves what's going on here. So I'm going to just say cout I. Let's see, I haven't. Whoa. Okay, anybody want to take a shot at what output this cout statement is going to produce? Or what you can tell me and what you can't tell me? Anybody want to get any shot at this? Okay, excellent guess. But what is that first item that's being printed? Oh, actually, okay, I see that there are several answers and I was only looking at one. Yeah, right, the first item there, int pointer, what's going to get printed is a memory address, right? The memory address of I. And then I'm going to get 4747. So let's actually just take a minute to see that in action. I think I should make this a little bigger. Oh, doesn't seem bigger. Oops. Bigger is. Whoa, don't know what I just did. Sorry. I'm in a little trouble. All right, well, let's go with this. G++ times CPP. All right. So there you can see, there's my memory address, and then there's my 247s. Any questions about why we got that output? All right. Next thing we are going to talk about is assignment of pointers. So let's look at a statement that assigns one pointer to another. Okay, so I'm not going to tell you anything new right now, but I am going to just kind of use what we already know to figure out what's going on. So I'm saying int pointer 1 gets int pointer. What that means in our picture is, all right, let's take what is being stored in int pointer and put it into int pointer 1. Okay, so I'm hoping that you can kind of predict what that's going to be. Let me just go through it. Remember that what's actually being stored here in int pointer is the memory address of I. So when I execute this assignment statement, what gets copied down here into int pointer 1 is the memory address of I, right? And the way we draw a picture of that is we make a pointer, make an arrow pointing to I. Okay, so the result of pointer assignment is you are making int pointer 1 point to the same thing that int pointer is pointing at. Point to the same memory location that int pointer is pointing at. So I just talked through that in quite a bit of detail, but what I want you to get out of this is that when you see pointer assignment, an assignment operator with a pointer on the left side and a pointer on the right side, the way you should think about it is, oh, I am making it so that int pointer 1 points to the same variable that int pointer is currently pointing to. Okay, so make them point at the same thing. Any questions about that? So let's just do another output statement here so we can see this for ourselves. Now I'm going to be outputting int pointer 1 instead of int pointer, but everything else is going to be the same. Okay, someone want to tell me what the second line of output is going to look like compared to the first line of output? No one wants to take a shot at it? Let me ask it a different way. What will be different between the second line of output and the first line of output? Let's give it a try. Exactly the same, right? Anybody want to ask a question about why that's the case? And if you look at the picture, int pointer and int pointer 1, they are both storing the same memory location now, right? They're both storing the memory location of I, so it makes sense that when I print the value of int pointer and I print the value of int pointer 1, they're going to be the same thing. Okay, any questions? Would be this, that would have the same effect in this case. Yes, that is correct, Sean. Just keep in mind that this is sort of a contrived situation here, because typically when we're dealing with pointers, we wouldn't know what the name of that variable I is, so we wouldn't be able to do it that way. But yes, that's a good point. That's another way of saying the same thing. Okay, next, I want to talk about pointers to objects. Generally speaking, there's nothing new in this section. I'm just going to start playing around with pointers just so we can sort of start getting the hang of it. There is one pitfall that we need to watch out for on this that that I'll be showing you. But other than that, generally, this is just let's play around with pointers a little bit and see how they work. I'm going to be using strings as the example here. And I'm not sure if we went into very much detail about strings earlier, and I don't think you've had to use them in an assignment. So I'm just going to digress for about 5 minutes here, and we're going to go back and look at strings, just because otherwise this example isn't going to make much sense. So if I can go back to our lesson 2.7, close enough, 2.6. Here's the lesson on string objects. There's also stuff about strings in the textbook. I think it might be chapter 2, possibly chapter 3. Let me just talk, I'm going to back up even further now. Before I even talk about strings, let's talk about why am I using the word variable sometimes, but when I'm talking about the word about strings, I'm using the word object. Anybody know the answer to that? What's the difference between an object and a variable in that context? All right, I will answer that question. By the way, I don't think I've had this conversation with you all, but I just want you to be assured that I do not mind long pauses in the conversation. It doesn't feel awkward to me. It just tells me that I'm assuming everyone is thinking hard about this and that no one knows the answer. All right, so when we use the word, an object is a special kind of variable. When we use the word object, we're referring to a special kind of variable that you can, that's more complex than a primitive variable. For example, you can do things like call a function after it by putting a dot and then the name and then the function call. Let me see if I can make this bigger. There we go. So you see that right here. We've got stir1.length, stir1.substir. Stir1 is a variable of type string, and it's this special kind of variable that we call an object. So with strings, basically, strings are just like other variables. You can declare them. You can use an assignment operator with them. You can read in a string using the extraction operator. You can print out a string using the insertion operator. But the special thing about a string is that you can say something, for example, stir1.length tells me how many characters there are in stir1. And then there's this other function. There's probably, I don't know, 50 different functions that you can call by saying, putting a dot after a string object. But here we have the substir function. And what that does is it just gives me a portion of the original string. So, and the way that works is this means give me the portion of stir1, starting with the character in position 3, and including 7 characters total. So if I were to execute this, I would start with the character K, because that's the character in position 3. We start at 0, so it's 0, 1, 2, 3. And then pick up the next 7 characters. So the output of this code segment would be KEY space SEE. Okay, not super important that you understand all the details of the stuff of the substir function. Just important to realize that you can call it like this, because that's what we're about to talk about back in lesson 12. Anybody want to ask a question about any of that or have me repeat any of that?
Yeah, I have a question. When you use those functions, do you have to like define them in your code?
No, this is built in. So the string class or the string type is built into C++, right? And so all of the functions that come with it are built-in functions.
Okay, got it.
Later on in the course, we're going to talk about how we can write our own classes and declare objects to be of the types that we create. And then at that point, we'll be defining the functions. But in the case of the string class, it's predefined. Okay, back to what we were doing. Oops, that's not what I meant. So, all right, let's just play around with this a little bit. I'm going to create a pointer to a string. I'm going to create a pointer. Oops. I'm sorry, I just said the wrong thing. I'm going to create a string. So I've got a pointer to a string that's uninitialized. And I've got an actual string that is initialized. So if I were to draw a picture of that, I would get oops. Here's stir pointer 1. And that has garbage in it right now. Here is stir 1. And that actually has the word hello in it right now. Okay, so everyone okay with the fact that those two lines of code on the left result in this new picture on the right? Any questions? Okay, now I'm going to make stir pointer 1 point to stir 1. So now it's no longer uninitialized. Now it is actually pointing at something. Everyone okay so far? So now I'm going to just print out the value, but I'm going to do it indirectly using stir pointer 1. Sorry, I said that slightly wrong. I'm not going to print out the whole word hello. I'm just going to print out a substring of the word hello. So what this means is take the value that stir pointer 1 is pointing at, and then take a substring from that value using the arguments 2 and 3. So what's the substring going to be? What's going to get printed there? Someone want to work that out and let us know in the chat? Okay, so L is where the substring is going to start. That's correct. But remember that second argument there, the 3, means how many characters there are going to be in the substring, right? So you're correct that it's going to start with the letter L because the letter L is in position 2, right? 0, 1, 2. This L right here is where the substring is going to start. But how many, but there are going to be 3 characters in the substring. So the result of this expression right here is LL0. So what should get printed here is LL0. Everyone okay with that?
Would it be LLO?
LLO, sorry, yes.
Hello.
Yeah, not LL0, LLO, thank you. Okay, any questions about why it's LLO? All right, and I guess actually, as a matter of fact, if that's not the focus of of what we're trying to learn here anyway, but it'll probably help things make more sense if you actually get that. Okay, here's the deal though. This is not going to work. It's going to cause a syntax error because of a really subtle point that I'm going to show you now. Okay. The problem is what we want is we want first dereference stir pointer 1. So we get the word hello, the string hello, and then apply the substring function to that string. However, in C++, this dot operator, okay, the dot operator, more technically, we would call it the selection operator because I'm selecting which function of the object I want, right? So this dot operator or selection operator has higher precedence than the dereference operator. So what the compiler is going to try to do is take this pointer and apply the selection operator to this pointer. You can't apply the selection operator to a pointer. It has to be an object. Okay, so if we were to actually compile this, let's save it. Yeah, okay. If I were to compile this, I'll get a syntax error. All right, here's a quick lesson in trying to read these super confusing syntax errors, right? Often you can kind of try to filter out all of this confusing stuff and find something that actually makes sense. So I would say here, error, member type, some complicated thing here, is a pointer, right? And then down here it says, indirection, that's the star operator, right? Indirection requires pointer operand. So the compiler is telling us right here in this expression that I have highlighted, which does not include the star, I'm trying to apply the indirection operator on, sorry, that's the wrong, sorry, I rewind, completely ignore that. Focus on the first error. The first error is that I can't use a dot here in this position because stir pointer 1 is a pointer. All right, how do we solve that? This is something that you should know, right? If we have an expression and we need to force C++ to evaluate the expression in a particular order, what do we use? The answer to that question is we use parentheses, right? That's the same thing in mathematics, right? We have an expression, we need to force the order of the operations to be different than what they would naturally be. We use parentheses. That's exactly what's happening here. Does it make sense that that's what's happening here? We have two operators here, and they are being evaluated in the wrong order that we want compared to what we need them to be evaluated in, right? We want the star operator to be evaluated first, but it has lower precedence than the dot operator. So we're going to use stars, we're going to use parentheses. Okay, now if I try this, I still get an error message. What happened? Oh, I didn't save it. Now if I try this, I get my LLO that I was expecting. Okay. Any questions about that pitfall there? Okay, not something we're going to encounter a lot, frankly, until we get to the last 2 weeks of the class and we study the linked data structure, then we're going to see this a lot. One last thing I need to say about this issue, and that is that, so this situation happens a lot when we're dealing with linked data structures. So when you get to your data structures class, you're going to see this constantly, just over and over and over again. And it's a pretty klutzy syntax, right? If I have to do this every time I need to dereference something and then select something from it, every time I need to use the star operator and the dot operator, I need parentheses here. It's pretty ugly. Not only is it used a lot, but you're going to find out in your data structures class, you're going to have like a single expression where this is going to happen like 3 times or 4 times. So C++ provides a shortcut for this to make it so that your code isn't completely illegible. What we can do is, instead of writing it that way, I'm going to leave that up there just so that you can compare the 2 different ways of saying the same thing. We're just going to say stir pointer 1 arrow substir 2 comma 3. Sorry, see that question? Let me just make sure everyone is okay with this new syntax that I just introduced. Trust me, when you get to your data structures class, you will get used to this. It just means, and so I call it, I don't think this is official, but I call this the, let me type it out. I call that arrow operator the dereference and then select operator. Okay, because that's exactly what is happening there. When you use that arrow operator, it means first dereference the pointer and then select the substir function from the object. Okay. Any questions about that before I change gears? Okay. As I'm saying this, I'm thinking to myself, boy, we just spent a lot of time talking about something that you're not going to see again until week 14, but you're just going to have to put that in your toolbox, and we're going to definitely have to come back to this when we get to week 14. You can use any function after that. Any function that is a member function of the string class can be used there. Okay, so another way of saying that is any function that I could have put here after the dot, I can also put after the arrow. Yes. There is not, to my knowledge, any nice acronym for C++ order of operations. For one thing, there's, I think, about 50 operators in C++, so that would be quite the acronym if there was one. PEMDAS does work, although there is no exponent in C++, so that part doesn't really help. But anyway, okay, am I done talking about pointers to objects? I guess I just want to actually run this one more time so that you can trust me that I actually am telling you the truth here. Oops, didn't save it because we only have the LLO once. We should have it twice, right? Because I'm printing it out using 2 different techniques. There's my LLO twice. Okay, any questions about pointers to objects? Okay, next. So basically what I'm doing now is I am just trying to think of some interesting things that we can do to just play around with pointers, sort of try to get used to them a little bit. So I decided I'm going to try, let's see what happens when we've got an array of pointers. So an array where each element of the array is a pointer. Okay, so the way I'm going to set that up is I'm going to declare a couple more string pointers and make them point to a couple more string variables. And then I'm going to put those pointers into an array. So string star stir pointer 2, string star stir pointer 3, string stir 2. Let's initialize that to the word there. String stir 3, let's initialize that to the word Penelope. And then let's make stir pointer 2 point to the word there. And then let's make stir pointer 3 point to the word Penelope. Okay, so let me go ahead and draw a picture of what we have so far there. So here I'm going to have stir pointer 2. And here I'm going to have stir 2. And stir 2 is going to contain the word there. And stir pointer 2 is going to be pointing at stir 2. Okay. And then I'm going to have stir pointer 3. Oh, yeah, that's right. Stir pointer 3. And stir 3. Stir 3 contains the word Penelope. And stir pointer 3 points to stir 3. Wider. Okay. Any questions about why this 6 lines of code over here results in this part of the picture? Everyone okay with that? Okay, so now what I want to do, what I originally promised you, is that I was going to create an array of pointers. So let me do that. Let's think about how this is going to work. If I wanted an array of strings, I would say string my array and let's say 10, for example, right? But I don't want an array of strings. What I want here is an array where each element is a pointer to a string. So it just means put a star there. And now that means that each element of the array is a pointer to a string. So let me draw a picture of that. Slightly wider. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's go ahead and mark our indexes. Okay, there's a picture of the array. Currently, it's just all of these just have garbage in them, right? Oops. All right, everyone okay so far? There's my array where each element of the array is a pointer to a string. So now what I'm going to do is I'm going to add a little bit to this statement. I'm going to initialize the first 3 elements of my array. For the first element, I'm going to put in stir pointer 1. For the second element, I'm going to put in stir pointer 2. And for the third element, I'm going to put in stir pointer 3. Okay. So what that means is in my array sub 0 is no longer uninitialized. Instead, it is a pointer to stir pointer 1, or I should, let me rephrase that. It's going to point to the same thing that stir pointer 1 points at. Right? So this is just like an assignment operator here. I'm saying let my array sub 0 be equal to stir pointer 1. In other words, let my array sub 0 point to the same thing that stir pointer 1 points at. Same thing with stir pointer 2 and stir pointer 3, right? Okay, whoa, that's not what I meant to do. Any questions about why this code over here results in this picture of the computer's mouth? Okay, sounds like we're in business. Let's play a little more with this. Let me say, star array sub 0 gets star array sub 1 plus star array sub 2. Okay, so in other words, take star array sub 1, which is the word there. Everyone, any questions about why this is just an indirect way of referring to the word there? So this means we're looking at array sub 1, which is this memory location right here. But because there's a star in front of it, we mean I'm not talking about this memory location. I'm talking about the memory location that it is pointing at, which is the word there. Right? Same thing with star array 2, star array sub 2 is going to be the word Penelope. So what this is going to do is it is going to put the word there Penelope into star array sub 0. So I'm going to have to make this a little wider. And this is going to be there. Okay. Any questions? Everyone clear on why the result of that assignment statement was to put the string there Penelope into stir 1? Okay. Let's just print this out to make sure that I'm telling you the truth. Good. Okay, I think that looks pretty good. Let's give it a try. If everything I'm telling you is true, then the output should be there Penelope, there Penelope, right? Oops, let's see what happened here. Oh, I know. I changed the name from my array. I suddenly started using the name array. You guys are supposed to be my helpers here. You're supposed to tell me if I do dumb stuff like that. We'll try that again. Thanks. All right. There's my array, there's star my array sub 0. There's star my array sub 1. There's star my array sub 2. Okay. All right. Any questions about any of that? All right. That's a pretty darn good start on pointers. That's as far as I got in the morning class. So I think just for the sake of consistency, I'm going to go ahead and stop there. If you have any questions about any of this, now would be an excellent time to ask. No questions about anything? All right. In that case, I will see you on Wednesday.
Thank you.
Thank you. Have a great day.
Thank you. Have a good day.
All right. See you all Wednesday.